What we're going to look at today is how to find a missing side using trigonometry. Okay, what we need to start with here is first some basic information about what you need for trigonometry. So firstly, this is always working with a right angled triangle. At the moment anyway. Later on you'll be able to do some other things with them, but for the moment in year 3 you will only be working with right angled triangles. So we have a right angled triangle here. I'm going to label it triangle A, B, C, just to be clear. Okay, remember always capital letters in the corners. Now, when we work with trigonometry, we need to always have what we call a reference angle. And when we're labeling with angles in geometry, we usually use Greek letters. So I'm going to use the letter theta here. This is the Greek letter theta. Greek letter theta. Okay, and this is just quite often used as a reference angle. In contrast to being specific about it, we could also call this angle alpha because it's on the point A. However, theta is just saying a reference angle. Okay, so this is a reference angle. And it just means the angle that we are working with. All right, now what we need to also then do is label the sides of this triangle. Okay, in the past we knew that we had the shorter sides of a right angled triangle and we had the third side, which we call the hypotenuse, and we're going to stick with the hypotenuse. So this is still the hypotenuse. Okay, but we also have to label these other two sides a bit more specifically because there's a big difference between working with this reference angle at the top here and working with the one down here at point C. Okay, they would give us completely different results. So we need to find a way of specifying which one of these we are working with. Now, the side that is over here, you could describe that side as being opposite the reference angle. So we are going to call this the opposite side. Nice and easy, opposite. Okay, the other one we are going to call the adjacent side. Okay, this is the adjacent side. Adjacent just means next to. Okay, so this is our reference angle theta, our adjacent side, our opposite side, and our hypotenuse. And as I said, we're now going to be able to use these with our trig ratios. So what are our trig ratios? We have this really nice saying that we use, and that saying is so ka toa. So ka toa. Okay, and this is a way of, it's a mnemonic so that we can memorize the formulas that we need here. So when you see so, for example, this means S stands for sine. Okay, and we say the sine of theta is equal to OH, and that means opposite divided by hypotenuse. Okay, and what you'll see is we usually just write it as sine with an S-I-N. It's really sine though, so this is actually written as sine. Okay, but we always shorten them, and you'll see that that's the same on your calculator. Okay, so sine on your calculator is written as S-I-N. So sine theta is equal to the opposite over the hypotenuse. So it's the ratio of the opposite to the hypotenuse. Okay, the next one is ka, C-A-H. Okay, and what that means is the cosine, and we write that as cosine of theta is equal to the AH. So A is your adjacent divided by hypotenuse. So this is our cosine ratio. Okay, and we're going to add that label here. Cos is cosine. All right, the third one is, you can see here, toa. Okay, and toa, T, stands for, if you look at your calculator, you'll see what the letters are. They are tan, and this means tangent of theta is equal to So the tangent of theta is OA, that is opposite over adjacent. Okay, and you've actually seen the word tangent before. We spoke about that when we looked at quadratic functions. Tangent also means that it touches something, but this is a different context for the word tangent, okay? Or it's got a bit more meaning to it, but it's a bit too much for you guys at the moment. So the sine of theta is the opposite over the hypotenuse, the cosine of theta is the adjacent over the hypotenuse, and the tangent of theta is the opposite over the adjacent. So when you memorize this so katoa, and I really recommend just writing it as soon as you go into a test or as soon as you're doing some homework, write so katoa at the top of your page. Okay, because then you know already all your formulas. Okay, what we'll do is now an example. So if I have a triangle, we'll try and keep these formulas. No, you guys don't need them. So if we have a triangle, let's draw a triangle like this. That's a very wonky right angled triangle. I'll try again. Okay, we have a beautiful right angled triangle like this guy. We will label it triangle PQR, and I'm going to make PR is going to be 5 meters, angle Q is going to be 35 degrees, and I want to know PQ. Okay, so we're going to make PQ X or whatever. Alright, so when you get a question like this, the first thing you should always do is label your sides with reference to that reference angle. Okay, so our reference angle is here. The side QR, you can see we're not actually using it. We don't have any information on QR, and we're also not trying to find it. So we're going to leave that one blank. Okay, so it doesn't confuse us, we're leaving it blank. You can see the 5, that is opposite the 35 degrees, so this is our opposite. And if you just write an O there, it will really help you. You don't have to write the whole word, just O for opposite. And PQ is, as always, the hypotenuse. So we have our so katoa. Okay, and if you look at our triangle, we have O and H. So which of these three uses O and H? Well, you can see it's this first beautiful one called so. So in that case, we know that we are working with the S, which was sine. Okay, so we have here sine of theta is equal to O, means opposite, so the first one goes on the top, opposite, over H for hypotenuse, so hypotenuse. And you can write them out short like this, that's fine, but you should always start with the formula. Okay, so the sine of theta, 35 degrees, and quite often you'll see it in brackets, just to be clear. That makes it a bit more clear for later on, especially when you start doing special formulas with these, is equal to opposite, and opposite you can see here is 5, divided by your hypotenuse, which is x. Alright, if I want to find x, well, we don't want x in the denominator, we want it back up in the numerator. So if we multiply both sides by x, so we're going to do x times on this side, x times on this side, you can see these guys will cancel. We end up with x sine 35 is equal to 5. Okay, but we didn't want x sine 35, we wanted x, so we're going to divide both sides by sine 35. We get x is equal to 5 divided by sine 35. Now that we can do on our calculator. Just give me a second to bring one up here. So we've got a nice little Casio here, and we're going to type in 5. And now this Casio has a nice fraction button, we can use that. So 5 over, and we want sine 35 in the denominator. So sine 35, close our bracket. Now, one thing you need to check is on your calculator screen, you should see this little D at the top. If you don't have a D, you need to change it. You might have an R or a G. If it's R or G, it needs to be switched to D, because D means degrees. R means radians, which you will work with when you do more trigonometry later. Okay, and G is another one that we're not going to use. So we want to see a D here and not an R or a G. So if you've got that wrong, you'll need to find out how to fix it. Usually it's in your menu or your setup here. Okay, but for now, yeah, make sure you've got degrees. Okay, so 5 divided by sine 35, we press equals, and we get x is equal to 8.72. So x is approximately equal to, because we're rounding, 8.72, and our units were meters. Okay, and while I now no longer need this, let's have a quick look. If you have this calculator, maybe shift setup. Yeah, so you can see here we've got input, output, angle unit. Angle unit is what we want, and we want degrees, so not radians or gradians. On the other Casio that a lot of people have, you need to just press the mode button, or possibly it's still shift setup, okay? All right, but this is how we calculate an angle, okay? For most people, the hardest part is choosing your ratio. Once you've done that, everything is the same every time. Doesn't really matter what question you're doing, okay? So good luck with that. Next lesson, we will talk about how to calculate an angle, but for now, this is how you calculate a missing side, okay? You just have to make sure you get the order of your formula right so that you put your x in the right spot.